Okay, so we put chapter 2 and 3 on hold and skip ahead to chapter 5 for two reasons. One, chapter 5 is more like what we were doing in chapter 1, and we build up some momentum and we'll just keep going on a similar topic. Two, physics is going to use some of the math from chapter 5 soon. We'll relearn this in physics, but if we get it in here before we get it in physics, advantage you when we do get this stuff in physics. So what chapter 5 is about is them giving you some partially known triangles. For every triangle, there could be 6 things known about it. What would be the 6 sort of things you could know about a triangle?
The measure of all the angles and all the sides.
Okay, we've got 3 sides, we've got 3 angles. That's 6 items. So what they're going to build up to through this chapter is give you scenarios where they're going to give you 3 items and expect you to give them back the other 3 items. Today we start off with the easiest one where we're going to do only right triangles today, continuing what we've been in chapter 1. Tomorrow, nothing will be a right triangle. It'll be other types of triangles with other sort of math skills we're going to need to build. But there's nothing new today. This is just sort of a warm-up for the kind of chapter you're looking at of here's a triangle, here's 3 things you know, get everything else known about it. The way the book will do it, they'll make it a draw your own triangle kind of motif. So they'll say you have a triangle ABC. Angle C is a right angle. So I'm going to draw myself a triangle. Where should the C now be? If I'm doing a triangle ABC, angle C is the right angle. I could label that. Bottom left. So that's my C. The measure of angle A is 27. We need to call one of these A and one of these B, and based on the information at hand, it doesn't really matter which is which. So what do you want this to be?
A.
A. B. If the measure of angle A is 27, the angle measurements are usually written inside the corners. We'll do that as our traditional right angle sort of measurement. What do you think this means? Yeah, which side do you think that is? The left, the right, or the bottom? Doesn't matter, does matter.
Bottom for adjacent?
I agree, but it's not because it's the adjacent. That's just a coincidence, because there's going to be an A, a B, and a C for these sides.
Is it always opposite of it?
It is the opposite of A. Since the A, angle A is here, if we go opposite of it, they're going to call this side A. When they refer to the angles, they'll use capital letters. When they refer to the sides, they'll do lowercase letters. So this would be lowercase letter C because it's opposite to C. This would be lowercase b because it's opposite to B. So right now that is 31.4, so there's our homemade do-it-yourself drawn picture where we know 3 items. Question about the draw so far? Then you're going to set out to get the other pieces. We want to know this side, we want to know this side, we want to know this angle. It's really up to you what order you want to do these things in. Anybody have an idea of how you could get anything figured out? Using either geometry or trig.
Label H's and A's.
We could. We don't have to do that yet, but we can. We could do some O's, A's, and H's and stuff in a second. Anybody have something we can get quicker than that?
The third angle.
Third angle. How can we get the third angle pretty quick?
180 minus.
Yeah. 3 angles have to add up to 180. So since we have a 90 and a 27, we can just use 180 and some subtraction to get this figured out to be
63.
Agree. Anybody bothered by the 63? Then I would do some O's, A's, and H's. I would probably do everything from 27's point of view, not 63's point of view. Anybody have a thought on why it might be wiser to use the 27 than to use the 63 as our point of view?
27?
They gave you the 27, so 27 is guaranteed accurate. We didn't mess up the 63, but there's a chance if we had messed up the 63, it could mess up a bunch of other stuff. So from this angle's point of view, this would be
Opposite.
opposite,
Adjacent.
adjacent,
Hypotenuse.
hypotenuse. Pick any of the trig things that has the O in it, because one of them, the O could lead you to A, the other one, the O could lead you to H. It doesn't really matter the order you do this. So any trig word with O in it. Sine,
31.
27.
always angle next equals
31.
over. Solving for x.
Switch sine 27 and X.
These guys just can switch spaces. Punch, 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 punch. I'm gonna say it's something probably in the 60s.
$69.16.
To go get the other side, you'd have two choices.
Square subtract root.
Square subtract root's probably the easiest choice. You could also have done something with tan or cosine or something else. I'd say square subtract root is your easier bet. That's probably in the 50s-ish.
$61.6.
Question about that?
How did you get the 69 and 16?
We punched in 31.4 divided by sine 27. Anything there on that triangle? If you want a quick check to make sure it's probably kind of at least has a chance to be okay, remember that the littlest angle needs to be opposite smallest side. Biggest side, opposite biggest angle. Medium size, opposite medium size. You can do a quick check of that. If something there is out of order, you're definitely wrong. That's not a super precise check, but that's at least something. Something that's a little bit better, remember that 30 angles were special. Do you remember what 30 angles did for you?
They were 1, or there was like a root 3.
30, 69.
Yeah. And what happened to the sides? If you had a 30, what happened to the sides?
Is it 1, 2, root 3?
It is. Like the opposite side has a certain relationship close to the hypotenuse. If this is 30, this should be half the hypotenuse. So 27 is close to 30. So I would expect this to be close to half the hypotenuse. 27 is a little bit under 30, so this should be a little bit under half. So seeing a 69, half of that's, like 34, 35. We're lower than a 30. 31, that really feels pretty good to me. Well, off of that trick, that's a little bit more of an exact sort of a thing to look for. Question about scheme number 1. Here they had a right angle, one more angle, and then a side. Question there. Let's take a step across the line into a new world. In the new world, we have, again, a right angle. Everything today will have one right angle, and that'll disappear tomorrow. And then they give you two sides this time. So if we go to draw our triangle, PQR, you have to be careful you Q the right angle in the right spot. So that has to be the Q. And then P and R could go wherever. Side Q to be 147 is which one? Hypotenuse. Side R is 72.15. It's across from the R. what we'd like to know is the angle at the top, the angle at the bottom, and also the missing side. And you can use any combination of geometry and trig. Anybody have a suggestion? Something that we could get?
The bottom side from square subtract root.
Square subtract root. We have the hypotenuse, we have the leg, you might as well get the other leg, just square subtract root. I don't know, 130, something maybe-ish. 120, 130, something like that.
128.76.
It had to be less than the hypotenuse, I figured. So. Then to go get an angle, it doesn't really matter which angle you want to go after. Pick one. Or, so I'll call that X. How could we get ourselves that angle?
Sine, cosine, tan.
Yeah, sine, cosine, tan kind of stuff, yeah. Since we picked this angle, this is opposite, hypotenuse,
Adjacent.
adjacent. We could use any two of these three numbers. Which two are the safest numbers to use?
O and
Yeah, why are O and H the safest two?
because you gave us the 10
They gave them to you. This could be
off.
off. We don't know. At the very least, this has been rounded, so it's at least a little bit like questionable. But those two are for sure, for sure. So if we use O and H, that's sine, X. And then how do we solve that?
Second sine.
Second sine. Anytime you're getting an angle, you're doing it inverse. That's the second button. So second sine, punch that in. It's going to be probably like about 28.
29.5. I mean 3.
Again, I saw the 30 thing coming. 72 is close to half of 147. Like half of 147 is like 73, 74. So this being half of that, I had a pretty sure that this was going to be close to 30, but a little bit under. Then the quickest path to get the other angle,
180.
just 180 stuff. We know two of these, so a little bit of adding, subtracting, 180 kind of action. This is 60.7. I'd do a quick check, make sure the biggest side was with the biggest angle, medium with medium, small with small. It is. We have the 30 trick working as well. That's what we're doing. That's the only two varieties. They have to give you a right angle. And then they have to give you at least one side. It's a question of some of the problems will give you two sides, some will give you one side, one angle. We're on whatever page the syllabus says. Is it 146? Anybody have a syllabus number? Feel like it's something in the neighborhood of like a 1 to 8, maybe?
146 on the.
So 146, 1 to 8, and that's a wrap on this.